So today we will start with the second method, right? So here in sliding window, right, technique, we will go with the second method. One is variable variable window size. Okay. Now, how do we solve the problems which are having the variable window size? Okay. Now let us take one example. Okay, one second. I'll just right. So we need to understand this variable size sliding window technique. Now these are the general steps which are involved. General steps involved in solving problem. Okay, let's look at all the different general steps, right? So basically we use two pointer technique. Basically we use two pointer technique to solve the problem. Okay, now like for example, right, left comma right, we will maintain two pointers. One is a left, another one is right. Okay, now generally, right, we increase we increase right pointer by right pointer one by one, right, till our condition is met, right, or till our condition is true, you can call it, right. Right, at any point if our condition, right, if our condition does not match, right, if our condition does not match, right, we shrink the window size. We shrink the window size, right, by increasing, right, left pointer. Okay, we increase, right, left pointer and reduce the window size. Again, right, again, when our condition satisfies, right, we start increasing, right, the right pointer, right, right pointer, right, one second, right pointer till step 2 is met. Okay, so right, follow these steps till, right, follow these steps till end of array. So these are the basic points, right, general basic steps which are involved in solving the problems using a sliding window technique. Okay, where we don't know the window size. Window size is not fixed. It can be of 2 element, it can be of 3 element, right, it can be of any number of elements. We don't know that, right. So in such situation we prefer using two pointer technique. Two pointers, we will maintain two pointers. One is a which points to the left of the window, left boundary, and right boundary of the window, right. Now let us take one example here, right, example problem, right, and we will understand it better. Okay, so let us take, right, the example problem here. So here the example problem is, right, okay, find the smallest subarray with sum greater, right, than a given value. Okay, this is the problem we are looking at. Okay, find the smallest subarray with sum greater than a given value. Now let us take a sample input here, sample input, right, where, right, number of elements is equal to 6 and the array elements are, right, 1 comma 4 comma 45 comma 6 comma 0 comma 9. So these are the 9 elements, sorry, 6 elements that we have. And given, right, given value, what is the given value? Let's take it as x and is equal to 51. Okay, so we will mark it as given value. Okay, so you need to find the smallest subarray with sum greater than given value. So this is the task. So what is the expected output? Expected output would be, right, right, expected output would be 3. So if you, right, look at explanation of this, you have a subarray with 4 comma 45 comma 6. This will give us the value as 51. Okay, this gives us as 51. Now let us consider the second one, right? We'll consider one more example, right? Sample input. Okay, let's consider one more sample input where n is equal to, right, 5 elements, right, and the array elements are 1 comma 10 comma 5 comma 2 comma 7. Okay, and the given x value is 100. Now here, right, expected output is 0 because we don't have any elements here. We don't have any element which will give the out, like given sum as, right, greater than 100. So that is why the output will be 0. Now how we can solve this using sliding window technique? So can we start with that? Okay, can we start with that? 45 plus 6, 51. See, 45 plus 6 is 51. That is true, right? 45 plus 6 is, right, 51. That is correct. But read the question correctly, right? You need to find a subarray where the sum is strictly greater than a given value, right, where the sum must be greater than, not equal to. Suraj, are you getting my point, buddy? So the sum must be greater than 51. So we need to add one more element there. Okay, so if it was equal to, then 4 and 6 would be correct, right? But here strictly it is greater than the given value. That is what we need to do. Now let us take these elements only. Let us take these array elements only and we'll start with our explanation. Okay, now, so, right, smallest subarray, right, with sum greater than, greater than, right, greater than, right, a given value, a given value. Okay, now, so let us take some sample input and start working on it. Okay, we will take an array, right, of 6 elements. Okay, let us take an array with 6 elements. So these are the 6 elements which we have, right? So 1, 4, 45, 6, 10 and 19. So these are the elements which we have: 0, 1, 2, 3, 4, 5, and these are the indexes, right? Now let us take the x value as 51. Okay. So these are the basic information that we have, right? So what we need to do here is first, right? Let us assume the right something called as, will take one variable called as result or answer. Initially we will keep it as, right? Okay, right, you can keep it as, right, 0 or any value. Now, right, what we need to do is first job is, right, right, so what we have to do exactly is we need to find a sub array, right, with a sum, smallest sub array we need to find, right, we need to find, right, a smallest sub array. Now what we will do is we will take one variable called as sum, initially keep it 0, right. Now keep on adding the first element, add the first element to the sum, right, add the first element to the sum. So what we will do here, 1. And also we will check whether the sum is smaller than the x value. If it is smaller than the x value, then add the next element, right, add the next element, right, add the next element. So again, if it is smaller than x, you keep on adding the next. So what you are doing is you're starting from this point, this will be your left, you're starting from the first element, where this element will be your left pointer. Okay, this will be your left pointer, right, and your right pointer was this first element you added, then you added, right, second element, then your right pointer will change it to third element, because our condition has not met yet, our condition has not met yet. One second, electronic pens. Okay, so you will add the next element. When you add the next element, what is the total we are getting? We are getting the total as 50. Still the condition x, the sum is till, still the sum is less than x. So we need to add the next element, right, we need to add, right, the next element. So we need to increment the right pointer and add the next element, right. So add the next element. So what will be the total sum now? The sum actually becomes how much now? 56, right. So it becomes 56, right. Now what we need to do is once we get this sum, right, once we get this sum, we try to manage, right, once, right, once the sum is found, once the sum found, right, then work on reducing window size, work on reducing window size. Now how do we reduce the window size here, right? So what we will do here is, right, we will keep on incrementing the left, you will keep on incrementing left, and you remove the elements. So total sum right now is 56, right, total sum is, right, as of now total sum is 56. Now what we will do is we will start from the beginning, right, the first element, this is our right end point. Now what we will do is we will start removing, right, one by one element from the left side. Now I will remove the first element, which is 1. Okay, now I'll remove the first element, which is 1, and the sum becomes, right, sum becomes, right, 55, right. Okay, so is 55, the sum value 55, is it still greater than x? Yes. Then try to remove the next one, which is right? 55 minus second element 54. If this sum is, if this sum is greater than x, keep repeating it. If this condition fails, then come out. Then come out, right? Then come out, right? And keep shifting the windows. This is what we keep doing it. Are you able to understand? Right? We removed this element. Now the left will be pointing to second element. Are you understanding this? Are you understanding this? Right? So you will maintain two borders of a window. One is left and one is right. You keep on increasing the right. You keep on increasing the right till you get a sum greater than x. Once you get a sum greater than x, you will start reducing the window size by removing one by one element. Okay, by removing one by one element, and you will keep on checking whether the sum is it still greater than x or not, right? Is it greater than x or not? This is what we should keep on maintaining. And after this we will also maintain the maximum sum, right? And minimum window size. We will maintain the minimum window size, right? Okay, so are you clear about this one? Okay, good. Now what we will do is we will start writing a program for this. We will start writing a program for this. We'll start with right, something called as C, and then we will write it in Java as well. Okay, so first of all we'll start it with a C language. Now what we will do is we will declare an array, right, with elements 1, 4, 45, 6, 10 and 19. So these are the elements which are present in the array. Now int n is equal to size of the array, that is 6. I'll directly assume it as of now. Then the x value what we take is 51. Okay. Now what we will do is we will call a function which will return us the smallest subarray with a sum greater than given x. So printf smallest sub array size percentage d double quote comma. You can call a function name and you can give the name it as smallest sub with sum, right? You can give any name. So we need to pass the array, number of elements and the x value. These are the three parameters that we need to send it to a function, right? It's a user defined function, right? We need to pass the three parameters. Since we are writing it in C language, whenever you pass an array as a parameter, we need to pass the number of elements also along with it. Okay, since this function is returning an integer value, return type will be int and the function name followed by three parameters, int arr comma int n comma int x. Okay, now I need few variable for traversing. For example, I is equal to 0, right, and j is equal to 0, or you can declare them and you can use them in the for loop also. It depends on how do you write a loop. Now since I'm not preferring using of a while loop, for loop, because I'll have a multiple conditions, right? So because of that reason I will use a while loop. I'll also tell you why it is required. And I need few more variable, that is sum is equal to, right, 0, and I need one variable called as ans, or we call it as result, to maintain, right, the smallest subarray size, the length of the subarray, the length of the subarray, right? So initially I'll take it as int max. Okay. Now if you are wondering what is that int max, okay, int max, right, int max is, once again, is a macro which gives biggest value of integer. If you want to use that macro, you need to include a header file called as limits.h. Limits.h. You need to include a header file called as limits.h, right? So these are the three few variables that we require. Now what we will do is we will start traversing array. Okay. So while, since I have already initialized variables I and j, I can use any one among them. J is less than n, till j is less than n. So you are traversing the entire array. This is used for traversing the entire array. Now this j will act as a starting point. Right here, j is left, right, pointer, and I is right pointer. This is how I'm using it. J is a left pointer and I is a right pointer. Okay. Now what we will do, first step is what? Expand window, right? Expand window until, right? Until, sorry, one second. Uh, J is, I is left and J is right. I'm sorry. I is left, right, and J is right pointer. Expand window until, right, sum is greater than X, until our condition gets satisfied. So how do we do that, right? We will run a loop here while, right, J less than number of elements, and also we need to keep a track, right, till the sum is less than or equal to X. As long as this condition is true, keep on finding the sum. Keep on adding the elements. Keep on adding the element. After adding the element, I need to keep on incrementing j. Right? I need to keep on incrementing j. That is the right pointer. It will keep on adding the next element. Right? This is how you gonna find, right, this first sum, desired sum, right, till this condition, right, it becomes false, right? Okay. Now once you get this sum, right, once you get this sum, the next step is what? Right, once you get the sum, what is the next step here? Minimize minimize the window size. Right, minimize the window size. So how do we minimize the window size? Then again run a loop, right, while left pointer is less than right pointer and sum minus arr of I is greater than X. See, what are we doing in these two condition is, right? See, I'll tell you in a pictorial representation. Instead of left and right, I'll show you. So currently, this is my I. I is having 0 and this is my J. Now I have found the total sum as 56. Now what I will do is I'll keep on removing one by one element from the left side. I'll keep on removing elements one by one from the left side. So I will keep on incrementing this I, right? How long I can increment I? Maximum I can increment I is till here. My I can traverse from 0 to 2. That's the only limit. So that's the reason we have written a condition as I less than j. This is a limit of removing the element. Okay. And also we are checking here if sum minus that left element arr of I. So what I value is initially 0. So here what happens, 56 minus 1 is greater than x. So if it is true, then only remove the element. Then only remove and increment I. Then only the remove the element and increment I. So these are the conditions that we need to check before removing an element. So what are we doing? So this is the boundary condition. You are traversing from left to right. Okay. And this is a condition, right? So to maintain the sum greater than x. So as long as the sum is greater than x, then keep removing. Sum is equal to sum minus ARR of I, right? Once you remove that element, increment the I variable. Increment the I variable. Okay, increment the I variable. So this will help you to get the desired sum which is greater than x. Now, so this is where it will stop. This is where it will stop, right? This is where it will stop. This is the exact place where it will stop. Now what we need to find, we need to find the length of that subarray. How do we get that length of subarray? J minus I, right? We will get, right, the length of the subarray as j minus I, which is 3, right? 3 minus 1, which is 2. How did we miss 1 here? 1 second. It's a post increment, right? It's a post increment. Okay. uh, Remove the check before. 1 second. 1 second. Sum minus ARR of I, you will remove, it will point to 1. Okay. 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 So, okay, fine, not a problem. See here. So, this is where I will be pointing. This is where I will be pointing. So, once you minimize window from the start while maintaining the sum greater than x, now what we need to do is, I have assumed already the largest, right? I have assumed the result as a largest element. So, I need to compare and keep a track of the smallest. If res is, if res is greater than j minus I, then res is equal to j minus I, right? So this is to maintain, right? This is to find the smallest, right, length of, length of sub array. This is to find the smallest length. We need to find the smallest sub array, right? I assumed one variable as with the largest length, and I'm comparing and keeping a track of the minimum length. Okay. Now once you finish with this, we need to remove the current start element and shift the window, right? Once you remove this, so remove the current starting element, right, and shift the window. Once you shift the window, how do we do that? Sum is equal to sum minus ARR of I, right, and increment the I value. So here in this one, we are trying to find the sum which is greater than x. Only if it is greater than x, then only we will subtract it. So only the first value is removed, right? Only the first value is removed. Okay. Then once you do this, right? Once you do this, now, right, you come out of the loop and return, right, res. This will give us the result. Now let us check and execute. Now the smallest subarray is 3. Are you understanding? 1 second, I'll just zoom out. Okay. First is traverse the array. Check one more time. Check, are you understanding or not? Go through that. go through that once. Since we got that value as 2, right? Since we got that value as 2, this is where it will get incremented in the last. Just to consider the element which was removed, that count will be taken care here. Okay, that count will be taken care here. Are you able to understand or not? Please respond. Go through that code. If you are not able to, then don't worry, we'll explain one more time. Okay, we will print